Hello, my name is Andrea Gauthier, and today I'm presenting on behalf of my co-authors on a paper we recently had published in Tokai, entitled Manipulating Interface Design Features Affects Children's Stop and Think Behaviors in a Counterintuitive Problem Game. This was an educational neuroscience-focused project based on a very simple idea. Children develop naive beliefs and misconceptions as they interact in the world, and these are especially common in science and math domains. For instance, they see that dolphins and fish have many similar physical characteristics and live in the same habitat, so they may intuitively classify dolphins and whales as types of fish. Or in math, they might develop a conception that perpendicular lines only consist of vertical and horizontal lines. So when lines are at an angle, like the purple ones, those must not be perpendicular. The problem is that even when they're taught the correct concept at some point, children often feel like they need to answer as quickly as possible, and so these more naive, more embedded beliefs come to mind much more easily than the correct knowledge. So the idea is that training children to stop and think before answering will allow them to suppress that initial incorrect response and allow time for the correct answer to surface. We developed a game called Stop and Think to train children to, you guessed it, stop and think before answering science and math problems, where classes played the game as a group with the teacher guiding the stop and think activity at the front of the room. They played this 3 times per week for 10 weeks in a large-scale trial, which proved to be quite successful. Let me walk you through the format of the stop and think activities. It adopted a classic game show style trivia genre, where the host would ask the class math and science questions. Then, panning into full screen, the question is narrated aloud, and a stop and think icon would pulsate in the corner for about 5 seconds or so to demonstrate that we should be stopping and thinking before answering, like in this clip.
Which of these animals are fish?
So it pulsates for a few seconds after narration. Then, once the pulsating icon goes away, the screen becomes interactable and the class can complete the activity. So here, we're answering incorrectly that a dolphin is a fish. Since we got it incorrect, the host says we can try again, and the game provides a series of scaffolded support to correct the misconception. So the motivation behind the current study was whether or not individualized training would be more effective than training as a whole group, because the software could potentially adapt to the unique needs of individual children. But before even thinking about adaptivity, we need to consider whether the current design of the interface is fit for purpose. For instance, is the pulsating motion of the icon totally distracting? So we decided to test what HCI features could guide children's stop and think behaviors more effectively when the game is not supported by a teacher. We investigated the pre-attentive cues of pulsating motion of the stop and think icon and symbolic color of the icon to indicate when the child should be stopping and thinking. We looked at a readiness indication mechanic where children would have to press a button after stopping and thinking to state their commitment to being ready to answer, which we argue is akin to hand raising in the classroom. And we looked at a rewards and penalty system where we hoped incentives for correct answers might slow the child down and be more careful about how they proceed. So we compared 4 conditions that combined these different features. The first condition was the motion condition, which was essentially the same as the original game. The second condition, which we called motion plus, applied the same persistent motion to the stop and think icon, but also incorporated the readiness indication mechanic through an I'm ready to answer button.
Which of these animals are fish?
So you can see here that the icon will pulsate for a few seconds, and then the I'm ready to answer button pops out to encourage the child to only proceed once they feel ready. The third condition, called Color Plus, also incorporated the readiness indication button, but swapped the pulsating motion of the icon with symbolic color. You'll see in the clip that red is used while the question is being narrated, yellow during the following few seconds to indicate that the child should still be thinking, and it turns green once the I'm ready button is pressed.
Which of these animals are fish?
Yellow for thinking. and then the I'm ready button pops out, turning to green at that point. Finally, the fourth condition, called color plus reward, builds on color plus by adding a token reward after each correct answer and a bonus multiplier for sequences of correct answers.
Which of these animals are fish?
So you can see a scoreboard in the top right corner, and the symbolic color and I'm ready button are exactly the same as in the previous condition. But you'll see here we'll get the answer correct, and we'll get a token reward and a bonus multiplier to encourage us to stop and think longer to ensure that we get the correct answer.
That is the correct answer.
We compared these conditions in a small randomized trial with 45 7 to 8-year-old children, wherein we tracked their gaze while they played a science and math session for 12 minutes. We measured their in-game performance, the average amount of time they spent stopping and thinking, where longer would be better, their eye fixations on the answer objects, again, where longer fixations would be better, and their eye fixations on the stop and think icon and I'm ready button, where lower total fixations would be better, since this would mean that they're less distracted and focusing on the problem. Overall, groups performed equally well in the game, so the HCI features ultimately had no impact on learning. The average time spent stopping and thinking was significantly higher in all conditions with the readiness indication mechanic, so getting children to state their commitment to being ready made them slow down and think longer. By comparing motion plus and color plus, we see that both motion and symbolic color cues appear equally effective at promoting longer thinking times. However, when we look at eye fixations on the answer objects, we see that there's no difference between motion and motion plus. Yet, there was a big difference between motion and color plus, which would suggest that there is an interaction effect between color and the readiness indication mechanic that promotes attention to the answer objects. I suggest that this is the idea that the whole is greater than the sum of its parts in design. Interestingly, the reward feature appeared to dampen the effectiveness of the color plus condition. Finally, if we look at fixations on the stop and think icon and the I'm ready button, particularly the comparison between motion plus and color plus, we can see that the motion did not distract children like we thought it would. In conclusion, we found that HCI design decisions can both positively and negatively affect children's learning behaviors. Yet, the evaluation of HCI in such a granular way is often neglected, especially in educational neuroscience fields where the research focus remains on the neuroscience concept. Assessing the efficacy of HCI strategies to support learning behaviors should take place before considering how learning technologies should adapt to individual children. Many thanks and enjoy the conference.